That's my second credit, sir. My second one.
Did I write your name down already?
No, you wrote it right there on the screen.
Okay, good.
That's my second one.
All right. So you got another to do by Friday. So when you go to this page, I don't know why I have to keep telling you, but you need to put your first name, print it neatly, and your last name, and the date that we're starting this lesson, whether you're in class or you're going to do it at home because you took the day off because of the weather. Today is 1/17, I think, of 24. It is same topic as I put in Canvas. Properties of logs. And I'm talking to my 2A class. So the videos that I gave you are good. Sometimes, though, they wait to the very end to summarize everything. Here's the deal. I'm looking at this example, generic example. If you are multiplying two things inside one log, you are allowed to break that apart into two separate smaller logs. That would turn into whatever base you have to keep it. Log base B of M plus log base B of N. Yes. I don't know, you're just playing too much to never know where I'm at or what I'm doing. So, this is called a product property. I'm going to explain to you why this is true. Do you remember what I said to you? That the answer to a log is always an exponent? Shh. Remember? The answer to a log is an exponent. So let me ask you a question. If I had 2 to the, let's see, 4 times 2 to the 6. What's another way of writing that? What's the rule of exponents? You add. Good job. Guys, did you hear Aubrey? She said we add. Now, add what, Aubrey? Do I add the 2's? No. What do I do with the 2's? You what? Multiply them?
Are you multiplying?
No.
Oh, they're multiplying.
I'm multiplying, yes, but what do I do if I want to rewrite this with one exponent?
Oh, you add their
Add their what?
exponent?
I do add the exponents. What do I do with the 2? Do I just keep it?
Yes.
2 to the 10, right? So here it's interesting. Notice we added the exponents. What am I doing here? I am adding exponents when I was multiplying something that had a base. When I was multiplying something that had a base. This has a base. This has a base. I keep the base. I add the exponents. That's the property, the product property of logs. Okay? So I'm going to do one problem.
So what's the
There's a stranger at the door.
Can you grab the door, please? He's not a stranger. He's a friend. So let's do one. Convert to a single log. Here's mine. One log. Let's go the opposite. If they're already added 2 logs, that means I want to put them together. Shh. That means condense. Gentlemen, you're still talking. I want to condense it. Make it smaller. That means I need only 1 log. 1 log base 3. Of what? No. No.
9 times 5.
Yes. 9 times 5. Because when we had 9 times 5, I could separate them with 2 logs. So I could write log base 3 of 45. Number 4. All right, he says expand it. That means break it apart into separate logs. So you got to think of a way. Give me something that would work. Got to factor what? 72? What times what is 72? Could you change that to a log, which by the way, base 10? Shh. Give me some numbers that multiply to be 72. I knew she was going to do that because a lot of people choose that. But I'm going to show you something crazy. That turns into log base 10 of 8 plus log base 10 of 9. That's true. Very good. I get full credit. Watch this, though. I can even be crazy. I'm going to be crazy right now. I'm going to turn that into log of a 2 times a 6. So it's 72 divided by 35. 6 times 6. I think that is 72. Check it if you want to. 2 times 6 times 6. Is it? Don't believe me. I make mistakes all the time. Is that 72?
Yes.
All right. So I could also expand it to more. I could do log base 10 of 2 plus log base 10 of 6 plus log base 10 of 6. Isn't that cool? No? Okay. At least you're honest. All right, next one. Quotient property. What's the rule? I'm just going to do it in reverse. What if I was doing 10 to the 8th divided by 10 to the 3rd? What's that rule about exponents now? Is she the only one that knows her algebra 2?
Yes.
What do you do with those? You want to keep it at 10? You subtract. You do the 8 minus 3. That turns into 10 to the 5. So interesting thing. When you're dividing like bases, you subtract exponents. Well, guess what I'm doing here? I'm dividing. So that must mean if I want to turn this into an expanded log, I keep the base, log base b, of the m, but now I don't add. I do what? I subtract log base b of n. Because I'm dividing. In one log, if you're dividing, you can break it apart into 2 logs of subtraction. Let's try one. Let's do number 7. I'll circle that as mine. All right. They're already subtracted. Gentlemen, you want to stay after class? Well, just ask me a question. Raise your hand and I'll. That's not a question. Scroll down to what? Slow down. Not too slow, because I got to finish these 3 properties.
Okay, we're good.
All right. So what operation of 1 log would I need to turn 2 logs with the same base, and it was subtracting 2 of them? I want 1 log. What do? I'm going to post this online anyway, what I just said. So 1 log. Do I add them or do I subtract them? Or do I divide them?
Divide them.
Yeah, I'm already subtracting. That means I got to divide. 96 divided by 6. Or is that, yeah, it is 6. Now, ask yourself, can that reduce? I mean, to me, that's a good answer, right? But, you know, some of you guys want to clean house and say, no, I don't like that. I'm going to turn the top, I'm going to cut them both in half. 45, 48, log of 48 over 3, if I cut them in half. Hey, wait a minute. I could have taken out a 4, couldn't I have? So what's half of 48? Or no, divided by 3, I'm sorry. Because there's a 3 here. 16, natural log of 16. So look at that. I took this very complicated subtraction of 2 logs. I ended up making it log of a 16. You can double check to see if these 2 answers are the same. All right, enough of that. I don't know what she wanted. She might have just stopped right here, which is good. How do I expand? I want to turn this into expansion using the quotient property. So that means I have to divide something with a log. Log base 3 of what? What could you use?
What?
What could you use to get an 8?
4 and 2?
4 divided by 2 doesn't give me 8.
Never mind. 16 divided by 2.
16 over 2 is an 8. That's perfect. So you just expanded this. Actually, is that what she wanted? I don't think she wanted that. I think she wants me to keep going. I didn't really expand it. Sorry. What if I say log base 3 of 16 minus log base 3 of 2? That'll work, won't it? That's expanded. This really isn't that expanded, but I think I had to do something like that. Last one. Power. This is the easiest one of them all. Let me ask you this. If I had a 4 and I'm squaring it, and then I have to take that answer and raise it to the 5th power, is there a way to write that with one exponent?
Yes.
A power to a power? Yeah, exactly. You multiply them.
4 to the 10.
That's 4 to the 10, which was 4 raised to the 2 times 5. Okay? So the power rule says that a power to a power you can multiply. Well, look over here. Condense into a single log. Okay, this is the answer to a log is a power. And this is a power. Because you can change this into log of 6 raised to the 3rd power. This number in front of a log, guys, can be put in as an exponent of the 6. Last one I'm doing. Expand this one. Do the opposite what I just did. Where can this exponent go? Where? In front. Log base 2 of 5 times the x. And if you are having trouble with those properties of exponents, okay. So I just got done going over all of an example of each of the properties. And you should be able to follow the videos I posted in Canvas to finish up the other 4, 8, 12. And then you should be good to go to move on to the next page, which is filling in some of the properties too. But what I want to do is talk about why these properties work. When you multiply like bases with like bases, like for x to the 4th, x to the 3rd, the answer was x to the 7 because we add the exponents. And if you remember that whenever you're multiplying like bases, which by the way, exponents are logs, so it made sense that when you had a log, let me get a pen here, a log of a times b, it makes sense that if the answer right here is an exponent, then obviously each log, if I break it into 2 separate logs, is the same as adding 2 exponents. And the division, the rule that you had in exponentials, exponents was when you divide with like bases, you always take the top exponent and subtract the bottom exponent, which is why x to the 7 over x to the 4 is x to the 3. Now, if you had it the other way, x to the 2nd divided by x to the 10, 2 minus 10 is a negative 8. And we would have written that as 1 over x to the 8. And if you think about it, if I had the log of a divided by b, and I break it up into separate logs, and each log is an exponent, and I'm dividing here, that must have meant I was subtracting exponents. So that turns into log of A subtract log of B. And the power to a power, well, 4x to the 4 to the 6, these two get multiplied. So 4 times 6 is 24. Well, again, if I had a log of x to the a, this is a power to a power. So we multiply. So you can rewrite it as an a times log of x. Okay? So I did that a little slower because I'm not with students, so it's a little easier to talk slow and not as loud and whatnot. So I hope you can finish this lesson up, and we'll touch base also with the next few pages.